equation for the alpha decay of radon, radium-226.
First time this year. Well, it's actually.
Okay, so what do you think of Suki's balanced nuclear equation? Thumbs up or thumbs down?
That's right.
Towards the
I don't like the yellow. I think better. You don't need to balance.
All right.
It's up.
So what do you guys
I
think?
think so.
Okay.
Yes.
Okay.
It's charge.
Now who's saying out of charge? Let's see. Oh yes, you can put the charge on the out particle. Okay, so this thanks to Bonnie and Joseph for writing this equation on the chalkboard. Okay, so let's go back one slide. So we know where radon comes from. Why is radon a concern in homes? So that homeowners can buy radon detectors and put in their basements and things like that. What's the big deal about radon? It's radioactive, but then so are all these other ones too. So of all the substances in this radioactive decay series, why is radon the chosen one? Yes, note it's got a half-life only of 3.8 days, but see, note that protactinium has a half-life of 1.17 minutes, so this one has a shorter half-life. Protactinium has a shorter half-life than radon.
Alpha rating?
Yeah, so it's alpha. And some of these other ones are alpha too.
Then they have the only one, well, from the elements that are higher up on that table, the only one with the shorter half-life would be protactinium. It's a beta emitter.
Yeah.
But there's something else too.
Yeah, it's polonium.
Polonium is the decay product of radon. That's also an alpha emitter, which has a half-life of 3.05 minutes. What's gas? Yeah, it's because radon's a gas. And since radon is a gas, that means that we can inhale radon. Now, we said that if we compare alpha particles versus beta particles, which one has the higher relative biological effect? Alpha. Yeah, alpha. So why is alpha particles more dangerous than beta particles? Yeah, so alpha is a type of ionizing radiation. So one way to think of this is that if you look at an alpha particle, so note that an alpha particle versus a beta particle. Now, what's the difference between an alpha particle and a beta particle? They're both particles, but what's the difference?
The beta particle is just an electron.
Yeah, so this is an electron, whereas the alpha particle is this is a helium nucleus. In terms of size, which one is bigger? Which one? Yes, not just large. This is very, very large, relatively speaking, whereas the electron is very small. So if a beta particle and alpha particle are traveling at the same speed, which one would you rather be hit by? It's smaller. So it's like being hit by a little pebble versus being hit by a, I don't know, like an bowling ball. Okay, so that's actually one of the reasons why alpha particles are a type of ionizing radiation. So when it's traveling through living tissue, it can ionize that tissue. Whereas when we looked at protection, what was required to shield a alpha particle? The skin. So it only takes skin to block an alpha particle. What was a beta particle? You did this in lab. What was required to block a beta particle? Yeah, lab coat. So you need, and it's usually because these beta particles travel faster than the alpha particles. That's why you need a thicker material to do that. So if this is you, okay, with your mouth open, that's you, and you're breathing in radon 222 in your lungs. This is your lungs. That's your lungs. Okay, so if radon is hitting your skin, it's not going to get into your body. So the way it gets into your body is you inhale the radon. George.
Did you have a story about a dog that was walking around the lab?
Oh, that was argon, not radon.
It was argon?
Yeah. Yeah, so let's see, argon is, where's argon? See, argon is one of the noble gases. Argon is above radon in the periodic table. Yeah, that was a story in which there was an argon leak, and then since argon is heavier or more dense than air, somehow a dog got into the lab and passed out. And that's how they detected the argon leak, and then the dog passed out. Luckily, they realized that all they had to do is take the dog outside and put it in the air. The dog is okay, so there was no harm to the dog. Yeah, so anyway, radon is a gas, so we have to be careful for that. Now, note again, what happened was that in some places the foundations in homes actually had some uranium in it. So in other words, the foundations in homes were made out of concrete, and then the concrete contains some uranium ore, which is uranium oxide. So that uranium oxide was poured in the concrete in homes, and really the danger is when you have an enclosed space. So in that case, that means if you have a basement, that radon gas can collect in the basement. Then if a person walks in the basement, they can inhale that radon gas. Now, if you have a garage, note that often the garage is open where there's wind blowing in, so that's actually okay in that case. On the other hand, there are always warnings about buying, officials telling us to buy radon detectors and putting it in homes and making sure there's no radon in there. Anyway, let's take a look at the radon map of California and see what it looks like in Monterey County. And let's try. Let's try. Okay, so radon map. Radon map. Okay, so here's one here. So let's take a look at the radon map. Here's a map of this country. So let's select California. And let's see what the Environmental Protection Agency says about radon. Well, I don't know why it takes so long to load.
Must be a big map.
Well, let's see. Let's click on here just because I'm getting impatient. Okay, here there's another one. Let's see. Here's a state radon contact. Let's see. Let's see. Here's another one. The energy.cr.usgs. Let's see. They're still loading. Okay, let's see. Let's take a look at
Maybe you Google California images.
Radon map of California. Okay, here's the radon map. Let's take a look at this one. So here's the radon map of California. And let's see, we're in Monterey, so the color tells us how much radon is in there. So let's see here.
We're good.
So this means, let's see, I can't even read that. 25 to 34. So anyway, percent of radon tests above 4 picocuries per liter. Now note that a curie is a unit of activity, and then pico is the prefix for for what unit. Like a picometer or a picocurie is 1 times 10 to the plus 12 or minus 12. Yeah, so a picocurie. Yeah, so pico is 10 to the minus 12. Okay, so a picocurie is 1 times 10 to the minus 12 curies. So anyway, in here for red, it's 25 to 34% of the homes showed a radon level above 4 picocuries per liter. So we're in Monterey County, so that's right in there. So let's see, does that correspond to this one or that one?
The lower one. Yeah.
So it looks like the lower one. And that's, according to this thing, 1 to something percent in there. So at least according to this map, at least we're okay.
But then if you go over to the radon by zip code.
By zip code, let's see, by zip code. Let's see, so we're somewhere
Look at the Monterey Bay.
Yeah, here's the Monterey Bay right there. Yeah, Monterey, but see, it's 1 to 5% positive tests. But see, it doesn't say if it's a positive test, what's the level of radiation there. So it's not really giving you, it doesn't really tell you how many homes are tested. And for example, if you test 100 homes and they say 1%, one gives a positive test, well, we don't know what the level of that test is. Okay, so just to make sure, so we take a look at one more map. What's this about? Okay, so maybe let's look at that. Oh, this one. Now it doesn't tell us. There's your California. Okay, we need to know what the colors mean though.
I think orange means okay.
Let's go back to this. Let's see. They show what the key is here somewhere. What do the colors mean? Okay, so let's see. Yellow means low potential, less than 2 picocuries per liter. Orange means, actually here it's sort of, see on the screen here it's yellow, so that's sort of yellowish green. And then here it's between 2 to 4, here's greater than 4. So let's go back to our picture again. Where'd it go? Okay, so let's see. So it looks like in Monterey County, we're level 2. So we're not really getting consistent data based on those 2 maps. So I would say, since you're young and you like to take chances, don't worry about radon. If you're old like me, then you say, well, I'm not sure if I want to spend $50 for a radon detector. Maybe. Since I don't have a basement in my home, I'm not going to do that. I'll keep the windows open, make sure there's ventilation, and the radon gas is going out of my house. Rolando.
Wait, so concrete will definitely.
No, it depends where the concrete was made. So I heard that that in Utah, actually, if there's one for, let's see if there's one for the country. Yeah, you can see one here. Yeah, I think in Utah anyway, in Utah, which is here, here's Nevada. Here's Nevada here. You see that? Here's Nevada. Here's Nevada. And then there's Utah and Colorado. So actually in Utah and Colorado, they had there's quite a few homes which were poured with concrete which had uranium in it. So that's why you see higher levels of radon in those homes in those areas of the country. So this sort of depends where you live.
Well, we need less regulation. We need less regulation so we can get more homes built.
Well, right now there's actually a glut of homes and people can't afford to buy. Well, people still aren't buying homes. So the real estate market is still in the Although if you live in North Salinas, I mean, 10 years ago there were hardly any homes in the Gulf Corona Road. Now there's so many homes. The traffic is so heavy. It's like a new part of town now. Anyway.
Like half an hour to get across town. 15 minutes.
Okay, so there's our radon test. So anyway, let's answer this question. Is it better to be exposed to an isotope with a long half-life or a short half-life? We also want to consider alpha emission versus beta emission. So maybe we can answer this question first. Would you rather be exposed to alpha particles or beta particles?
Oh, beta.
Why beta?
They're smaller.
Yeah, so the relative biological effect of beta is smaller.